So who am I? Just a quick little bit about myself. First and foremost, I'm an Airflow committer. Been working with Airflow about 3.5 years, June 2021. I'm also a senior SDE at Amazon. Been working there about 7 years. I was one of the first employees on the MWAA product. For those that know that, helped build and launch that service. And then shortly after, segued to bootstrapping a new open source team. So it was a group of us who make open source only changes to Apache Airflow. Dennis being one of them. I spent much of this last year working on executors again. So as kind of alluded to in the previous talk, for those that were there, I helped lead the AAP51 decoupling project, making it easier to write your own executors. And then along with the team, wrote a couple of executors. And this year was working on hybrid execution, so running multiple executors concurrently, which is what we're going to talk about today. So a bit of background, again, just really quickly, what is an executor? You guys know a lot of the details now, but a short summary, executors facilitate running tasks. So the scheduler decides when is a good way to think about it, giving the time in your schedule and dependencies. And an executor decides where and how a task is run. Scheduler regularly heartbeats the executor and communicates with it over an API, progresses tasks through states, gets events back. The executor runs as part of the scheduler, which is important to remember for a lot of the upcoming slides. It's not its own process that runs in a separate host. Executors are not pluggable and extensible. You can write your own. Read the last talk. So there are many types of executors. I'm going to group them into 3 main groups for the purpose of this talk, but you could delineate them more further. The first one is local executors. So these are executors that run on the same host that the executor is running on, which is in the same host that the scheduler is running on, as we just talked about. So these ones are really easy to use. They have very few requirements to set up. They're very fast because they run on the same host. There's nothing going over the network. But they're also limited in the capabilities in that they share resources with the scheduler, which is not great. So if you're running a super expensive task locally that needs a bunch of CPU and memory, that's going to harm your scheduler performance. So we have other remote executors, which could be broken down into 2 groups. The first one is a queued sort of batch executor. Think Celery. So these are executors that send tasks to a central queue, and workers pull from that queue. So now you're decoupled from the scheduler, which is good, better for performance in that way. You can have some large host listening to that queue. You can even have them persistent, so they're ready to take tasks from that queue instantaneously. So now you're just paying the cost to get to the queue. So the SLA is still pretty good. You can run multiple tasks on those workers, so that makes it very cost effective. You can sort of bin pack the tasks. So that all sounds pretty good, but if you are running those tasks in parallel on the same host, you have the noise and Eber problem we just talked about. It can also be expensive to have these idle workers. If you don't have a workload that's consistent, maybe it's spiky, you have some workers sitting there not being used, or you have to do auto scaling, which is complex and a little difficult to get right sometimes. And the last is sort of remote containerized executors. These are tasks that run one-to-one inside a container or a pod. Think the Kubernetes executor. So the pros of this is you're getting no noisy neighbor. It's impossible. Each task runs within one container for the lifetime of that container. You can completely customize that container. So maybe you have some special system libraries or dependencies or some data that you need in those containers. And Airflow allows you to send a particular Airflow task to a particular container. It's cost effective and the container only lives for the lifetime of the task, but you pay a huge latency cost. It takes time to start up that pod on every task. So if it's something short and quick, a little fire and forget task, it's not great for that. You have workers to manage, but you also now have a Kubernetes environment to manage, for example, which is not entirely easy, depending on the kube skills. So the point of all of that is that executors have pros and cons. You're often like trade-offs between latency, isolation, cost efficiency, complexity of running the executor. So if you could run multiple, that would be great, you know. Say if you had a low latency task that you need to fire forget, local executor is great. You had some tasks that are okay to run beside each other, but maybe you need more resources. You can use Celery executor, some bigger workers on standby. And if you need very bespoke environments, you can use Kubernetes executor. But one size doesn't fit all. So, ta-da! Now in Airflow of 2.10, you have hybrid executor or multiple executor configuration. Been going through a bit of a rebrand. You'll learn why in a few slides, why we're trying not to use hybrid executor, but everyone knows it as that. at the time. So we're still kind of using that. So let's talk about how you use it. I hope that the code is visible. I try to make it as big as possible, but it still uses the same core executor field that we all know and love and we've been using for years, except that config can now accept a comma-delimited list of executors. The first executor in that list, in this case local executor, is the default executor, which is important because that's the executor that's going to run any task that you haven't specified a specific executor for. So if you're running 2.10 and you bring some DAGs over from your previous Airflow versions and you don't make any changes, that first executor in the list is going to run all of those tasks. We have aliases, or short names here in this case. So custom modules are often specified as a module path, which is really annoying to deal with. You'll see in the next slides. So we allow those. Oh, sure, sorry. I don't know if we can turn up volume, but I can just talk a little louder. Yeah, so we have short name aliases you can provide for custom module paths and make it a little easier to use. You'll see how to use those in a second. And core executors are still referenced by their name that we're all familiar with: local executor, celery executor, in this case, and Kubernetes executor in this example. So here's an example, some operators on the side here. This is a DAG, or a snippet of a DAG at least. So this first example, hello world 1, using the bash operator. It doesn't really matter what the operator is. You can see there's a new field executor, very aptly named. And this one has had the value short name. So this one's using that alias. You can see this one up here. The alias. This is a made-up module and doesn't exist, but just for illustrative purposes. So that one's going to run on this custom executor. The second task is using task flow, but still that executor field is present. And this one is specifying Kubernetes executor. So this task will run on the Kubernetes executor. And you can see this bottom one, which will look familiar to most of you, or other than missing maybe some params that you use. There's no executor field. Nothing is specified for this one, since this is what your DAGs are going to look like coming from pre-210. So that one's going to run on the local executor, because that's the first one in the list. So that's the part we're trying to hang on for. You can also specify an executor for an entire DAG. This, we just make use of the default DAGs. This is something that's been in Airflow for years. It's not been reinvented. It's just a convenient way to pass parameters to all of the tasks in the DAG. And so here, for example, this entire DAG we know can run on the Kubernetes executor. So that's what we're providing to default DAGs. So every task in the DAG will run on that executor. But you can override them. Default DAGs are just the default. So if you had a DAG and you knew that 90 out of 99 tasks are going to run one executor, maybe you can configure that, and maybe the other 9 you go in and specify a precise executor. So how to keep an eye on things. This is a little bit about telemetry, some metrics. If you're using a single executor, so you've moved to 210 or onwards and you're not making use of multiple executors, the metrics will look exactly the same. A lot of the changes we made for this project were meant to be backwards compatible as best we could. But if you're using multiple executors, the class name of the executor will show up in the metric name. This is important to remember if you've built any dashboards about executor metrics. Those dashboards may break because those names are going to look different, so that's important to keep in mind. Logging works just the same. You just have more executors. And as we know now, executors run on the scheduler, so that's where your executor logs show up. That's where they've always shown up. You'll just have more of them. So you need to pay attention to the module name in the log message to tell you which executor is giving you that message. But other than that, it'll all show up in the place you've always known them to show up in. And task instances now, the database records themselves, keep track of the executor which executed them. So you'll be able to see in the Airflow web server, you click on a task instance that ran in the DAG, and it'll tell you which executor ran. And these are all plumbed through the Airflow API. So if you want to query for all tasks that ran on a particular executor, for example, that's totally possible. And so every time I tell someone about Hybrid Executor, there's usually some FAQs, so I try to capture some of them. Maybe we can get to some more interesting questions after the talk. The first one is always, what if I configure my task to use an executor that doesn't exist? So you have your Airflow core executor config, and maybe you've put a couple executors in there, but someone has gone and written a DAG and asked for an executor that wasn't configured. The DAG's going to fail to parse. Airflow is smart enough to check which executors you've tagged tasks to run with, and then check if they're configured and present. And if they're not, it's going to yell at you. In the same way that the DAG failed to parse for any other reason. I'm sure you've all seen those. You'll get the dialog in the UI, and you'll need to go in and fix your DAG. It'll tell you which task and which executor are the mismatch. And then what about the reverse? If you add an executor to core.executor, so Airflow knows about it and it's initialized, but you have no tasks that are using it. This is totally fine. Airflow is going to start that executor. It's going to call the start method that you all know about now. It's going to initialize that executor, and then it's just going to sit there happily, not getting any work. It's going to be heartbeated every scheduler loop, but that's fine. It should have no tasks to move through or send updates for, so it should be a no-op. Depending on how your executor is written, if you have a custom executor that does something expensive every heartbeat, then you probably shouldn't be doing that, but if you do, you'll pay that cost every time. But other than that, it is pretty safe. And the last one is, what if you change the executor configuration between or even during task executions? It's fairly safe for the tasks that are tagged to use a specific executor. So if you're tagging a task to use local and you've added a third one to your executor list, it should be fine. The only problem is if you remove executor that a task depends on, then you're going to have issues. You're going to have the first bullet where you get yelled at for DAG person. And the other thing to remember is the default executor. If you change that, that falls through transparently. Every task, again, who isn't tagged to use this specific executor is just going to use that default, whatever it is, happily. So keep in mind that that will change. And here's a note on the old executors. A lot of people are familiar with, say, the Celery Kubernetes or local Kubernetes. This is where the name change came from, because those truly are hybrid executors. The two executors mashed together in a class. They kind of abuse the queue field to direct which executor they send their tasks to, which means you can't use that queue for its intended purpose. Having a concrete class for every combination of executor that you'd like to use is kind of untenable, right? We have a bunch of executors now, and the combinatorics and coding up a class for every combination you might want to use is not great. And they don't use the public interface for executors. At least it's complicated, but a little nuance. But changes to the base interface often don't propagate down very well, and these things break very regularly. They've broken twice in the past month, for example. So I encourage you to stop using these as soon as you can. They'll be deprecated soon. Please use to move to a multiple executor configuration as soon as you can. I have a little demo of it working. I didn't trust the demo gods to do this live, so it's a recording. I hope that's clear for most people. Maybe it's a little fuzzy on the projector, but you can see we're using pretty latest build of Airflow 3.0 dev. This environment just has one DAG in it, and we'll show you the configuration first, show you which executors we have configured. Who's going to zoom to the executor configuration. You can see we're still here using core executor, and we have two executors defined in this case. Local executor, which I seem to love to use as the default, but it doesn't have to be. And then Celery executor is the additional executor, which will not be used unless you tag a task to use that executor explicitly. We're going to enable it, show you the code for a second. Pretty simple. Queue imports a couple of tasks. The first task is called Hello World Celery. It, very surprisingly prints hello Celery. And it uses that executor field in task flow. It specifies the Celery executor. And this task level local, again, surprisingly, prints hello locally. No specification of an executor, so as we should expect, that should run on the local executor. And give this a run in a second. This DAG. It's already off to the races. The local task finishes very quickly. It's already done. And the Celery follows up shortly. We'll just pop this open, look at the logs, just to show that everything worked. Hello locally, as we expect. Celery prints hello Celery. We'll go to the task instance details. This is what I was talking about before, where you can see which executor ran. So we have this new field called executor. This will show you the executor that ran this particular task. And then with the local executor, since that was the default, we don't put an executor there because it didn't map to anything specific. It's just whatever the default is at the time, which can change at any moment. So we just mark that that was ran on default because it's not quite relevant what the default was at the time. Like, it can change at any moment. If you retried this task and changed the default, it would be a new executor. And this is my favorite part of this demo, the Gantt view. So you can see the differences between the two executors. The local executor is very fast. It ran almost less than a second. You can see the Celery executor, and all of this was local containers, but still, the Celery executor took some time to send the task to the Celery queue, and then the worker had to read it from the queue. And then once the worker had the task, it ran just about as fast, if not maybe a teeny bit faster. So this is just an interesting way to illustrate the differences between the two executors. We're going to go back here and pop open Vim for a second. Sorry for those who use a fancy IDE. I still code in Vim in the 90s. I'm going to break the executor configuration. You're going to set it to foobar, which is a non-existent executor. Don't try to use it, it doesn't exist. And the DAG parsing is going to fail. You can see the exception you see. It's going to tell you the executor foobar for this particular task isn't configured. I don't know what to do. Please fix this. And I'm going to go back and fix this again. Just revert those comments and save. Have DAG parsing to happen, configured to happen very quickly here. And you can see it's happy again. And the DAG will run to completion, just as we had it before. And that is it. I hope you make use of this. It's a new feature. It's available now. A lot of these talks at the summit are about stuff that will be available in Airflow 3, but this one's pretty fun because you can go use it right now. So give me a shot and know what you think. It's experimental at the moment, but the more people who use it, the more we'll stabilize it and move it to stable as quickly as we can.